Welcome to this video. In this video I will be showing you how to train a machine learning model for a custom object detection using TensorFlow 1. So head over to this link. I'll be giving this link in the description. I've explained this in much more detail over here in this article, so go ahead and check it out. Okay, so let's get started. We'll quickly go through these steps. There are 17 steps that I have devised, as you can see, to train the model. Okay, so to begin, just click on this Colab notebook over here. Okay, so once this has opened, just click on File, save a copy in Drive. This will create a copy for you in your Drive. So now you can use this Colab notebook. Okay, so let's begin. So for the first step, we have to install TensorFlow 1. Connect this. Now before we start anything, connect this and make sure the runtime type is selected as GPU, as I've mentioned this over here. Okay, so it's connected. Change runtime type and just select this as GPU. Mine is already selected. Okay, so now let's begin with the first step. Pip install TensorFlow 1.15. This will take a while, so just be patient. Okay, so this has successfully installed TensorFlow 1.15. You can check this by printing the version. Okay, so we have this version installed. For the next step, import dependencies. Again, I have also mentioned all these steps over here in this Colab notebook, so you don't have to go over to this blog every time. This blog just has more detailed explanation of all these steps. So okay, so let's continue over here. Second step, import dependencies. Okay, for the third step, create custom TF1 training and data folders in your Google Drive. Create a folder named custom TF1. Let's do that. Custom capital TF1. Okay, now next, create another folder named training inside the custom TF1 folder. This training folder is where the checkpoints will be saved during the training process. And then after this, create another folder named data inside the custom TF1 folder. Okay, so inside this folder we need to create two folders. The first one, training folder. The next one, data folder. Okay, so that's done. Now let's move on to the next step. Create a folder named images for your custom dataset images, and create another folder named annotations for its corresponding XML files. And then next, create the zip files and upload them to the custom TF1 folder in your drive, collecting images dataset and labeling them. I've already labeled all my images and I've placed them in these folders. The images are over here in the images folder, both with mask and without mask. Those are the two classes that I'll be working with. And for the annotations, the labels, these are the labels for it. Over here, as you can see, the XML files, these are the Pascal VOC format labels for all these images. Put them in these two separate folders and create their zip files. Now upload both these zip files to the custom TF1 folder that we created, this one. So file upload, desktop, TF1, both these two zip files. And one more thing, just make sure you use this JPG format only, as the PyScript that we'll be using in the next step 5 over here, only has JPG format written in it. So if you use these other formats, it won't work. If you have to use other formats, you can make the changes in this script accordingly. So you can find the script over here for collecting images data set and labeling them. You can read more about that over here. I've made an article on this for dataset labeling. I've also made a few videos on this, so go ahead and check it out. This will help you understand the labeling process in much more detail. I have also given a brief overview of that process, how to label your dataset, in this article. Again, for more detailed explanation, just go over and check out this article. Okay, so let's get back to it. Okay, it has uploaded both these files. Now for the next step, upload the generate TFRecord.py file to the custom TF1 folder on your drive. You can download it from here. I uploaded this on my GitHub. So as you can see, we have the generate TFRecord.py file over here, and the other files as well. Okay, I'll be explaining about these other files later on. Okay, so upload this. I've already downloaded this. Upload it to the custom TF1 folder. Okay, that is it. Okay, for the next step, mount drive and link your folder. On this step, allow, copy this authorization code, paste, enter. Okay, what this line does is it creates a symbolic link so that this path is now equal to /my drive. You don't have to write this every time. So that's what it does, and then list the contents in this path. As you can see, I have my custom TF1 folder over here. Okay, so let's move on to the next step. Clone the TensorFlow model's Git repository and install TensorFlow object detection API. Okay, so let's run this. Let's clone this TensorFlow model's Git repository in our current location, the current working directory that we have, which is in the content section over here. This is the current working directory, the content folder. So as you can see, we have a drive mounted over here. Now this will clone this model's Git repository over here. This is what we need, and then change directory to models research, compile, and then install TensorFlow object detection API. This is the official installation procedure for this, for TensorFlow 1 setup, as is mentioned on this in this article over here. As you can see, the documentation page. I've also given all these links at the bottom of my page under references and documentation, so we can go ahead and check them out. These will be really helpful. Okay, so the step that we were on is over here. As you can see, the page that I opened, you can see this is the Python package installation for TensorFlow 1. Okay, this is given in the documentation page for this object detection. We have it for TensorFlow 2 as well. So that is a different procedure. I'll be doing that in the next video. For now, let's focus on TensorFlow 1. Okay, so once we have the object detection API for TensorFlow 1 set installed, so okay, let's move on to the next step. Test the model builder. This just confirms if everything was installed correctly. Okay, so you ran 21 tests. Okay, so everything is fine, there was no error. So let's move on to the next step. The ninth step, navigate to my drive custom tf1 data folder and unzip the images and annotations.zip files into the data folder. So okay, first let's navigate to this folder, this path, and then we'll unzip both these images and annotations.zip files. Okay, as you can see, we have a drive over here. We'll be navigating to this folder, and then we will be unzipping these two, this file annotation.zip and images.zip into this data folder. Just run this step. Okay, so that's done. For the next step, create test labels and train labels. Just make sure the current working directory is this one. Yeah. And next we'll divide the annotations, this annotations folder. As you can see, now it has all these XML files in it, and the images folder will have all the JPG files. Okay, so for this we'll create one folder named test labels and another folder named train labels, and we'll divide them into this ratio. Test labels will have 20% of the annotations and train labels will have 80% of these annotations in them. So since I have 1370 images, 20% of that is 274. So that's why I've written 274 over here. You can change this according to your total number of images. And then for 80% of images, the rest of the images, this will just copy it into the train underscore labels folder. Just run this. Okay, so now as you can see, it has created both these folders where test labels will have 20% of the files from annotations and train label will have 80% of the files from annotations. Okay, for the next step, create the CSV files and the label map.pptxt file. Again, make sure your current working directory is the same as this one. Then run this script, XML to CSV script. This will create these two CSV files, test_labels.csv and train_labels.csv, and then it will also create this label_map.pptxt file, which will have the name of the classes that I mentioned in the XML files. Just run it. Okay, now it has successfully converted train label XML to CSV. Okay, successfully created. Now as you can see, it has created all these files. The label map.pptxt has the names of all the classes mentioned in it with its ID. So again, it starts with the ID number 1. The ID 0 is reserved for background. So 1 and 2, that's how it should be. Then look at the test_labels.csv file. This is how it should look like. Yeah, remember, each image can have multiple classes. Similarly, make sure the train labels.csv file. Okay, this is fine. Now for the next step, create train.record and test.record files. Again, current working directory is the same. Run the generate_tf.record.py script. Okay, let's run this to make sure we're in this directory. Okay, that's fine. Now let's run this command. For train.record python, we run this generate_tf_record.py script file that we uploaded earlier, and then give the path to the CSV file, our label map.pptxt file, our images folder, this one where we have all the images, and then finally the output name. This will create the train.record file, and this will create test.record file. Now as you can see, for train.record, as I mentioned earlier, we have 80% files. So this has successfully created the TFRecords, and as you can see, it's showing 1096, that is 80% of my total number of files, that was 1370. And the next one is 274. Out of 274, that is 20% for test.record. So it's perfect. You have to check this to see if there are any errors. Okay, now after this we can move on to the next step. Download pre-trained model checkpoint. So now for this we'll be using the SSD mobilenet v2 Coco pre-trained model, so for TensorFlow 1. Now one thing, we can use various other pre-trained models for training purposes, but I'm using SSD mobilenet. So okay, just click on this link. This will download and unzip the SSD mobilenet pre-trained checkpoint over here. This is the latest checkpoint 2018-03-29. Okay, now get the model pipeline config file, make changes to it and put it inside the data folder. Now there are two ways you can do this. You can either download this SSD mobilenet v2_coco.config file from over here. Let's close the drive and open this models folder. Inside this we can go in research, object detection, inside this samples and configs. So we have a configs folder over here, but this is for TensorFlow 2. We don't need this right now, we need it for TensorFlow 1. So that will be in samples, configs, and this has the config files for various other models. We can use either of these models for training, but over here I will be using this config file that I mentioned earlier, SSD mobilenet v2_coco. You can download this and open it, and you can edit this using a notepad, or we can use the second method, just simply make changes over here itself. We'll make changes over here and then simply copy the edit file to this location, my drive custom tf1_data folder. So let's make the changes over here. Change number of classes to your number of classes. I have 2, so I'll change this to 2. Test record path and train record path and label map path. Okay, so go down at the bottom. As you can see, train input reader, this needs the path to the train.record file, and this needs the path to label map.pbtxt file. And over here the same for label map.pbtxt file and for test.record. So all you have to do, where we have our training test.record, okay, so just copy path, paste this over here, copy path, paste this over here, label map.pbtxt file, paste this over here and do the same over here. Okay, we're done for this step. Now for the next step, okay, change fine tune checkpoint to the path where the download checkpoint from step 13 is. In the previous step we downloaded this pre-trained model checkpoint. So over here, if you go above fine tune checkpoint, it needs the path to the model.checkpoint file. Previous step we downloaded this zip file and then we unzip this over here. So this is where we have our model.checkpoint. So just copy the path to it and that is it. As you can see, I have given the path to model.checkpoint over here. Okay, now for the next step, change fine-tune checkpoint type with the value classification or detection depending upon the type of model you're training. I'm training it for detection, so I'll write detection over here. For the next step, change batch size to any multiple of 8 depending upon the capability of your GPU. So right now we are in Colab, so I won't give it a very large batch size. I'll just start with a simple 24. That is it. Okay, the batch size over here is 20. I've set it to 24 and change number of steps to the steps you want the detector to train it to. Now we can leave this as it is over here. The number of steps is set to 200,000. So we can change this in the command later on as well. But if you want to set it to a specific number, just mention it over here. That is it. Save it. Okay, so now it is saved, and we can simply run this. This will copy that config file to this folder, data folder. Now you'll see we have the config file over here, and it will have the changes that we made, as you can see. So just recheck this, then we can move on to the next step. Load TensorBoard. Run this. This is the path to the training folder where we'll have our checkpoints saved during the training process. So at the moment it will not give any output because we haven't started the training process. Okay, so for the next step, train the model, we have to navigate to the object detection folder. This is the folder that we'll be navigating to: models, research, object detection. Okay, so we are in this object detection path. Okay, this is the command that we'll be using. Okay, so now we'll run this command, python model underscore main.py, and then the path to the config pipeline that we edited and copied. And the next, this is the model directory, that is the path to the folder where we'll save our checkpoints during the training process. And that's it. Okay, now this will begin the training process for you. Okay, so this is going to take a few hours to train, depending on the number of steps and the number of images that you have. Now, since I have given 1370 images and 200,000 steps, so this will take a few hours. Now what this does is that this will save the checkpoint every 100 iterations. So as you can see, we're now at step 0, and now next, after a while, it has jumped to step 100, and also it saves the checkpoint at fixed intervals. So we'll have the checkpoint over here, checkpoint 0, the next. So in case we get disconnected, we can restart the training process from where we left off using the checkpoint that was saved last over here. I'll show you that later on. For now, I'll just pause this video and come back once it has reached at least 1000 steps. Okay, so now we are at step 1300. So let's see if it has saved any checkpoint. Okay, as you can see, after 0, it has saved checkpoint at step number 1188. So just in case if we get disconnected, okay, so right now, remember, we didn't make any change. Now this will automatically find the last saved checkpoint and begin training from there itself. Okay, so as you can see over here, saving checkpoints for 1188 into the model.checkpoint, and we'll begin training from over there. So that's how we can restart the training process in case if you get disconnected. So okay, just one more thing, you have to train this until if the loss is less than 1 if possible, else train the model until the loss does not show any significant change for a while. So as you can see, right now we're at 4.07, so we can wait until this goes below 1. Try to get it as low as possible. Okay, so now we are at step number 168358, so 168,358. so as you can see, now the loss has gone below 1. So I'll just stop the training over here. You can keep training until you feel there is no significant change in the loss for a while, so that will be good. Depending upon the type of your data set and the number of images, this can vary. Also, we can make a few changes in the config file. As I've mentioned over here, we can add many data augmentations and various other changes to better our model. So okay, now we're done with the training process. Okay, so now for the final step, last step, to test your trained model. First we'll export a frozen instance graph. Again, make sure the current working directory is the same as this one. And now this will be the command to create the inference graph. Python export inference graph. We have the export inference graph by file over here inside the subject detection folder. This one. Again, the next input type will be image tensor, pipeline config path, data, the one that we edited the config file. Again, then the train checkpoint prefix. This will be the model checkpoint number, the latest one that we have, the one that you want to pass in this command. Over here, as I can see, I have the latest checkpoint number 168158. So just write this, just change this number over here, and then finally the output directory where we'll create the inference graph. Just run this command. Just check and make sure there are no errors. Okay, as you can see, writing pipeline config file to this path, so it's done. Now okay, yes, we have the inference graph folder over here. Let's open it. We have the frozen inference graph over here. Let's download this. It is of approximately 18 megabytes, as you can see over here. Now for the next step, to test your trained object detection model on images. Again, the current working directory is this the same as the one above. Just make sure we're in this directory. Again, now this step is optional. This is just to change the size of the fonts for the object detection boxes. It just makes it more visible for me. You don't have to do this. Now finally, this is the last step, the main step that we'll use to run inference on a few images. Now this is the path to the image directory. Now I have a few images over here inside mask test images as image 1, image 2, image 3, and so on. So I'll just write the path over here, directory mask test images, and I'll give it both formats, JPG and PNG. And then next we have to write the path to the labels. Again, that is the same as we did for the config file. Just copy path, and you can paste it over here. And that is it. Next, path to checkpoint, the inference graph over here. Leave it as it is. You will be fine. This is just to make you understand what is really going on over here. So this is the path to the frozen inference graph. Again, this over here to this PB file. Okay, and rest everything seems fine. So you can edit this depending on the values that you need. You can change the minimum score threshold. This is the minimum accuracy required for detection. And then the line thickness, you can change this to whatever you want. Just to run this for first few images. So what this does is it runs this for all the images ending in this format .jpg or .png using the checkpoint inference graph that we created in the previous step. Okay, so now this can take a while depending upon the images present in this folder. This passes all the images inside this directory. Okay, just one more thing. We also have to change these values. Change this to your number of classes, and you can set this to whatever image size you want to display. Okay, let's go down below. As you can see, now it has detected all these 3 images that were in my drive. Okay, as you can see, it has detected all these masks with 99, 94, 100 and 87% accuracy, and the next one is without mask with 100% accuracy, and again in this one as well, for this it is without mask and with mask. Okay, so that was the last step to test the model. So this is how you can train an object detection model using TensorFlow 1. So okay, that's it for this video. So if you've enjoyed this video, please click on the like button and make sure to subscribe to this channel. And okay, I'll see you in the next one.